Hello everyone, welcome back to my YouTube channel. In previous videos we have discussed about real numbers and rational numbers. In this video we'll be discussing in detail about irrational numbers. So let us start. Let us understand what are irrational numbers. An irrational number is a real number that cannot be expressed as a ratio of integers. For example, root 2 is an irrational number. So in the previous video we have seen that there are two types in real numbers, rational number and irrational number. The number which can be expressed in a ratio is rational number, whereas the number which cannot be expressed in ratio are irrational numbers. In the word itself, irrational. Rational means it's the form of ratio and irrational means it is not in the form of ratio. An example of irrational number is root 2, root 3, root 5 and so on. We cannot express any rational number in the form of ratio such as p upon q, that is numerator upon denominator, where q is not equal to 0. Again, the decimal expansion of irrational number is neither terminating nor recurring. In previous video we have seen what is terminating, non-terminating, recurring and non-recurring type of numbers. So irrational number comes under non-terminating, non-recurring type. It is denoted by symbol p or r minus q or q dash. Now p means it is set of irrational numbers, r is set of real numbers and q is set of rational numbers. If we subtract rational numbers from real numbers, we get irrational numbers. So we can represent it as r minus q or q dash. Q dash means the numbers apart from rational numbers. So we basically represent it at q dash. Is pi an irrational number? Yes, pi is an irrational number as it is neither terminating nor repeating decimal. The value of pi is also not equal to 22 by 7 as 22 by 7 is a rational number while pi is an irrational number. But since the value of 22 by 7 is nearly equal to 3.14, which is nearly equal to value of pi, so we take 22 upon 7 as the value of pi while solving sums. The value of pi is 3.1415926 and so on. So it is non-repeating decimal and also non-terminating. That's why it is an irrational number. Let us have more examples of irrational numbers. Many square roots and cube root are also irrational, but not all of them. For example, root 3 is an irrational number, but root 4 is a rational number. Why so? Because 4 is a perfect square, such as 2 multiplied by 2 is 4. Hence we can write root 4 is 2. Similarly, 3 into 3 is 9, so we can write root 9 is equal to 3. So root 4, root 9, root 25, root 16, root 36, root 49, these are all are rational numbers since they are perfect squares. It should be noted that there are infinite irrational numbers between any two real numbers. For example, 2 and 3, these are real numbers. Between 2 and 3, there are many infinite irrational numbers. 5 and 6, between 5 and 6 there are infinite irrational numbers. Let us see how to find irrational numbers between two real numbers. Let us find irrational numbers between 2 and 3. Now we know that the square root of 4 is 2 and square root of 9 is 3. So therefore the number of irrational numbers between 2 and 3 will be root 5, root 6, root 7 and root 8. Since root 4 is equal to 2 and root 9 is equal to 3. So between root 4 and root 9 there are root 5, root 6, root 7, root 8. So these comes under irrational numbers as they are not a perfect square. Root 4, root 9, these are perfect squares of 2 and 3. Similarly, if one tells you to find irrational number between 5 and 6. So for 5, the perfect square of 25, that is 5, and perfect square of 36 is 6. So irrational numbers between 5 and 6 will be root 26, root 27, root 28, root 29, root 30, root 31, root 32, root 33 till root 35. So these will be irrational numbers between 5 and 6. Similarly, you can also find irrational numbers between any other two perfect square numbers. Now we have to prove that is root 2 irrational number? Yes, we have seen that many examples saying root 2 is an irrational number. So how we are going to prove that root 2 is an irrational number? Now, to prove any number to an irrational number, we have to prove that that number is not a rational number. If we prove that root 2 is not a rational number, it will be indirectly proved that it is an irrational number. Let us start with the steps. So let us assume, this is my first step, to assume that root 2 is a rational number. So first we are assuming that root 2 is a rational number. So if it is a rational number, we can express it in the form of p upon q, since rational numbers are nothing but expressed in the form of fractions in the form of ratio. Now p upon q is a reduced form of rational number, reduced form, so hence they have no common factors other than 1. For example, 5 upon 2. Do they have any common factors? No, this is a reduced number, reduced form of fractional. So they only one common factor, that is 1. Similarly, 1 by 2, they have only one common factor, that is 1. So any number which is expressed in fraction, so they have only one common factor, that is 1, and there is no other common factor in them. So we can write at root 2 is equal to p upon q, as we have assumed root 2 as a rational number, taking square root on both sides. So we will get root 2 square, that is 2, is equal to p square upon q square. Taking this q square on LHS, we will get 2q square is equal to p square. Now from this equation we can understand that p square is an even. How? An even number is multiple of 2. So here you can say p square, it is multiple of 2. It is multiplied, q square is multiplied with 2. So we can say that p square is even. Now since p square is even, p is also even. How we will know that? See here. 2 is even number. What is the square of 2? 4. 4 is a even number. Square of 4 is 16, which is also even number. So square of a even number is also is always even. So we can write p square is even, then we can write p is also even. So if the number is even, we can conclude that 2 is a factor of that number. So 2 is a factor of p. This we have concluded since p is even number. So this is our equation 1. Let us move to the next step. Since p is an even number, we can say that p is a multiple of 2. Thus p is equal to 2t, where t is any constant. Squaring the equation, we get p square is equal to 4t square. Okay, now we have already found in the previous step p square is equal to 2q square. So substituting the value of p square in this equation, so we'll get 4t square is equal to 2q square. Upon simplifying this, we'll get q square is equal to 2t square. Now from this equation we can observe q square is a multiple of 2. So q square is an even number. Since q square is even number, we can say q is even, since square of a even number is always even. Now since the number is even, it is 2 is the factor of that number. So in equation 1 we got that 2 is a factor of p, and equation 2 is that 2 is a factor of q. Now from both the equation we can say that 2 is a common factor of pa and q both. Thus our assumption is wrong. What we have assumed that root 2 is a rational number, and rational number is that number which is in the form of fraction and it has no common factor except 1. But here we have got one common factor, that is 2, but rational number has only one common factor, that is only 1. So this is against our assumption. So we can say that root 2 is irrational number. It is not a rational number, it is an irrational number. Similarly, with this method you can prove that root 3 is irrational number, root 5 is irrational number, and many more examples. So here we end our today's session. If you found the video helpful and interesting, do like, share and subscribe our channel. Thank you.